Hey everybody, so it is now time for me to present all of my findings for my science experiment. Yeah, let's just get right into it. So the title of my experiment is The Effect of Scramble Distance on Human Solvers. So that's the first time anybody is hearing that. No, that's a lie. Not anybody in the world, obviously. But what does this mean? So let's keep going. So I'm assuming that most of the people who are going to be watching this are cubers, so I'm not going to go over these definitions, but you do need to know things like God's number and distance. So God's number is the maximum amount of moves required to solve a Rubik's Cube with any scramble, and this is 20. So no matter how mixed up you have a Rubik's Cube, you'll never be more than 20 moves away from solving it. But you can actually go lower you can go lower per scramble. So if you have a certain scramble of distance 15, then that means that particular scramble can be solved in 15 moves, but no less. So according to God's number, distance will never go over 20, but particular scrambles can have a lower distance. So the question I was trying to figure out is, does a higher scramble distance lead to slower human solving times? AKA, does a person solving with a distance 20, will that make them slower than if they were solving with a distance 18? So one thing I guess keep in mind is that a human can't actually get a perfect solve. I mean, you can through FMC, but it takes a long time. Computers are very, very efficient. And people are not. So depending on your method, people tend to solve within 40 to 60 moves. A computer can do it in, whatever the distance of that scramble is every single time. So, I'm not saying that people are going to be matching computers or anything, but despite this, I still think that the scramble distance could have an effect on human solving time. So that's why I did the experiment. The materials I needed were not very extensive. I just needed a computer, a cube solving program, which I'll talk about in a second, internet access, and a Rubik's Cube. So this program, it's called Cube Explorer. It's very useful. You can use it to prove distances and make algorithms. So I particularly used it to prove distances. For example, if you follow the steps I have highlighted in red, it'll actually tell you what the distance of your scramble is. So anytime I used a scramble in this experiment, I always put it through this program to make sure it was the distance that I wanted and I wasn't misjudging things. So then when I actually had to construct my scrambles, there's this website. It's called cube20.org. It was made by Thomas Rokicki, and he proved God's number back in 2010. But basically, on that website, there's a list of all the distance 20 scrambles that he has, and I used those distance 20s obviously for distance 20s, but I also used them to create smaller distances. So for example, if you want a distance 18, all you have to do is take a distance 20 scramble and then remove the first two moves, and you have a distance 18. So using cube20.org, I created every scramble for this experiment. And then when I actually went to collect my data, I did it in a Google form. So what I did is I collected my data in sets. So set A was my distance 20s and set B was my distance 19s. And I did this from distance 20 to distance 13 because I wanted to see if there was any correlation. And so the survey looked something like this. It looked exactly like this. This is a screenshot. But you would have 3 scrambles and then 1 extra, but the extras ended up not really getting used. So basically the participants would read these scrambles, put their results in, and then all of this data gets sent into a spreadsheet here, which I was very amazed, very thankful to have 133 people participate in the survey. That's amazing. Thank you. If you participated and you're watching, thank you. Basically, every single row of this spreadsheet, which is 4 screenshots put together, by the way, every single row in this spreadsheet is one person. And then these these like yellow and blue things at the top, this is like distance 20, this is 19, and this is 18, you know, and so on, down to 13 down here. So this like giant box of white, these are all times that people gave me, and that's pretty cool. So thank you, everybody. But besides that, we can get on to the results. First, let me give you my disclaimer. So first of all, I'm not a professional scientist or data scientist or anything. There could be things I'm overlooking. I'm missing some statistical significance tests, like the t-test or whatever you call it. But so basically, some of this stuff, it's missing in a few areas. I'm not saying everything I'm going to show you isn't true, but just know that this is not professionally done. This is just an amateur experiment. So that's my disclaimer. Here are my results. So basically, yeah, my trend of all my data is showing that distance 20 is harder than the rest. But what's interesting is that things get a little funky, I guess. So I expected to either get data that looked like this, or like this. This was my no correlation vision, and then if there was correlation, I envisioned something like this, but that didn't happen. We have things like distance 20 moving down to distance 19, but then here things start rising again, and then there's this bottom at 16 before it rises and falls again. All this weird stuff going on that I can't really explain. My only guess as to why 16 is like down here would be, so I think other cubers might experience this sometimes, but if you see a scramble that's like really quote unquote lucky, it tends to get in my head, and I'll pressure myself to do good to the point where I'll perform worse than I'm expected to. But maybe distance 16 is this perfect medium where scrambles aren't lucky enough that people are performing worse, but they're not hard enough that people are performing worse. There's like this middle here, but this is very so highly likely to be untrue of a guess, and you'll see, because in other trends that I'm going to show you, things look a lot different than this. Because in my survey, I also asked questions about background experience, method, averages, so we can see the breakdown of different demographics of people, and we can see what their trend line looks like. So now let's look at the slower cubers trend line. So here's where interesting things start happening. 20 is the highest again, but now we see things like 14 is the bottom, and there's this sharp incline at 13 at the end, and then in here there's this block where everything's just kind of moving back and forth. I don't know, does this mean that correlation gets stronger as times move down? Are slower times more unreliable? Is there no correlation in general? I don't know. But yeah, this is the trend line I got for cubers slower than 30 seconds. Now, this is middle ground cubers, I called it, and this is slower than 20 seconds but faster than 30. So now we can see that this that from 20 to 16, that's a horrible curly brace. What am I doing? From 20 to 16, there's a very defined trend. But past 16, things get a little more undefined, because now we've got a bottom at 14, and we've got this sharp incline again. So what's happening here? I really have no idea. But on the bright side, what I am going to do is I am going to make all of my data public. So if you want to look at my spreadsheet, it's a copy, and I've removed personal information. But besides that, it's still the same thing. You can look at all of my data, and you can see what's going on for yourself. So if you want to try and answer the question, what's happening at 14, you can go right ahead and do that. But this is the trend I got for middle ground cubers. So now I bunched these next two groups together because this trend is just going to get more defined on my next slide. But what's really interesting here is now we see things like an increase at the start of the graph. So 20, for the first time, is now slower than 19. Things start by moving up. And the other interesting thing is that 14, now it's not the top of the graph, but I'm seeing like a peak. So while before 14 would be our bottom, it'd be like down here or something, 14 is now seeing like a sharp increase. So I don't know why this is happening. I don't know if this like negates my data or anything, but this is what I got for my fast cubers. And then what's really cool is the fastest cubers have this like upside down U shape. Basically 20 and 19 are like on the faster end, and then there's this plateau with the exception of 15. It plateaus at the top and then shoots down again at 13. So I have no idea why this is happening. This is really cool to me. I was kind of like, I was shocked, but I was actually kind of happy to find a trend like this because it's just really interesting. I don't know why something like this is happening. I know I've said that so many times, but it's true. I don't want to lie to you. I don't know what's going on. But yeah, so the faster cubers, maybe they know something that we don't about these harder scrambles. Not sure. So now I'm going to go into results based on method. I'm going to go a lot quicker through this. I put it all on the one slide because the trends are all generally moving downward. You know, I have things like Petrus and other methods, which, and beginner kind of, these get more unreliable just because there's not as many people involved. In the other methods, like I don't even know why I put that in there. It's just trying to take three completely different things and put them together. But basically, yeah, you know, even though like Ru and ZZ, they don't have as many people by like a lot, it doesn't seem like your method is going to affect you as much. So I'd want to say that scramble distance isn't like discriminatory to method. So really, no matter what method you're using, you're still going to get similar trend lines and similar downward trends with other methods. Something else really cool, I asked questions on competition participation. So this trend is actually another one of my favorites because it's like kind of a reverse of itself. Now let me show you what I mean. So here we see like a peak, a valley, a peak, a valley. This gets flipped on the other graph because now we have a peak, a valley, and a peak. And you can see that these are sort of mirroring the positions. So what is that word? So while we have a valley at 19 on this graph, we have a valley at 19 on this graph, we have a peak at 19 on this graph. And when, like 17, 16 gets a peak here, we get a valley at 17, 16 down here. So what's really interesting is that these graphs are kind of mirroring each other. But basically, I just don't know exactly what's going on. I know I've said that a million times, but yeah, this is really cool. I like this graph a lot. The last thing I did is, for those of you who did the experiment, you might remember that there was one lonely scramble at the end, and that's actually the quote-unquote hardest scramble. So on Q20.org, they highlighted a scramble that took the longest for the program to solve. And I just called this the hardest scramble, and I wanted to see how people performed on this versus the rest. So this 20 column here, this is the average, the overall average of the distance 20 times. And this is the overall average of the hardest scramble times. I called it 21 just to be funny. I don't know. We can see that distance 20 is actually slower. So, I guess computers aren't actually that great at telling us what a hard scramble is and what an easy scramble is. So looks like the hardest scramble isn't actually so hard for people. And now, here's my conclusion. Okay, so my hypothesis isn't clearly supported. There appears to be a correlation, but it also appears that there's like a lot more happening behind the scenes, more variables at play, things I don't know what's happening. But basically, if you're a cuber, don't worry about your scramble distance. Okay, like this isn't supposed to be something that's gonna be like life changing or anything, because down here you probably already read this, but distance 20 has point everything, all these zeros, 1/1/3 chance of occurring. It is super, super rare for you to get a distance 20 in competition. So don't worry about it. Don't freak out. You're not going to your times aren't going to slow down. This pie chart here, this is 18. So this is our majority. And then in this little sliver, which my laser pointer is covering, this includes not only distance 20, but I think distance 15, 14, 13 through 0. So obviously, you don't need to worry that much. And even one of these, this let's see, this blue here is 19. You don't even have to worry about it that much, because if you paid attention to the numbers that I had at the side of my graphs, they're not large changes. So if you do, say you're the luckiest man alive and you get a distance 20 in a competition, you're probably only going to do 0.5 at the max, worse. It's going to be less than that even. And, who knows, if you're Felix Zemdegs and you get a distance 20, you could break a world record. I don't know. But yeah, don't worry about what distance you get. That's my conclusion. And hypothesis not clearly supported. Errors and unexplained occurrences. I don't really need to go over this because I already did as I was doing it. Possible errors in my data. There were only 3 scrambles per set, so perhaps if for my distance 20, instead of having 3 scrambles and 1 extra, maybe I should have had 5 scrambles and 1 extra or something like that. The reason I did 3 and only 8 sets is because I didn't want to overwhelm or discourage people from doing it. I already, just with the amount of scrambles I had people saying, wow, you sure had a lot of scrambles in your experiment. So I wanted to make sure that I had a small enough number that people would still be motivated to do the experiment. And then sets are not encountered in a random order, so everybody did distance 20 first, and then 19, and then 18, and then 17, and there was no randomness, and perhaps some people were applying their stuff incorrectly. It's possible, but I am assuming by the fact that I got 133 people to take this, that the overwhelming majority will be applying their scrambles correctly, so that the incorrect appliers would just get drowned out, but maybe they're still having some small effect. Here's my bibliography, cube20.org, some of the social media sites that I use to promote my stuff, Cube Explorer's website. These are probably formatted horrible because I just threw them through an MLA citation generator. And then my acknowledgments, thanks to all these people, they're great. So yeah, closing remarks. So this is supposed to be my overview. Now, this probably 20-minute video is a little more than an overview. But I do also have a research paper. Again, not a professional. It's not professionally written or anything. But it should go slightly more in depth, and it has everything written down. So if I talk too fast or something, you can go ahead and read that. It goes more in depth than what I just gave you. So you can read the research paper, if you want to know more. And then also, if you are really curious about this, if you really enjoyed this video or something, in the link of this video, you will find the research paper, and you will find all of my data. So you yourself can you can make a copy of the spreadsheet, and you can do whatever you want. You can make trend lines, you can do t-tests, you can knock yourself out, do whatever you want. just only thing I ask is that if you do more with this, please tell me. I would love to see what you guys do. If you're going to take this to the next step, just please like reach out to me, let me know what's going on. I would love to be involved. But besides that, that's basically it. That's my overview. Thank you so much to everybody who participated. I cannot stress how happy I was to see that 133 people took the experiment. So thank you. I'm sorry that I sort of took a decent bit of time to get this out. I know a lot of you were excited and eager to know what's going to happen. But yeah, thanks for watching. I can't wait to see what you guys do with this experiment. So thank you. Goodbye.